Okay, so on question 19, what we're looking for is we're trying to find the values that could be solutions. We're not actually going to be solving these for an actual answer. We're just trying to look at this and see what could be a possible answer. And what we do not want is we want no division by 0. So when we look at these, we have to find out what numbers could be in the domain, okay? What could be possible solutions? And we can't have division by 0 because any number divided by 0, remember, is not a real number, it's undefined. And we don't want that. So we need to make sure that when we look at our denominators, that 0 can never happen, because that would make it, if we got that as a solution, not make sense, not a feasible solution. So what we do is we look at each denominator separately. So we look at each one independently, and we solve each one equal to 0. So we set each denominator to 0. So we're going to set each denominator equal to 0. And you may have multiple values that can exist, or you may just have one. So we're going to set each denominator to 0. We don't care about the numerator, the top half at all. That's completely irrelevant. So we're going to set each denominator to 0. So x minus 1 equals 0. We'll add our 1. And that's going to give us one number that won't work, which is going to be x equals 1. Because if I plug 1 in, 1 minus 1 here gives you 0. And we can't have 4 divided by 0, so that's undefined. And then we look at the other one. Well, the other one is 1 minus x equals 0. So we do the same thing, move it over. And then we get minus x equals minus 1. We divide by our minus 1, and so x equals then 1. So what number can we not have? There's only one number that we can't have, and x equals 1 is not a solution. So x equals 1 is not a possible solution. And while we're here, let's go ahead and find our domain. Okay, domain is the values of x that are possible. And so the domain would be negative infinity to 1 union 1 to infinity. Okay, that's going to be your domain. And basically what that's saying is every number could be a solution except for 1. Because 1 gives you division by 0, and we can't have it. So this is kind of the background for several of the others. And I do kind of mix them up, that we have to kind of think about things in your homework. But I wanted to do 19 first, because 19 then builds into, it's going to build into that question 7. And so we're going to kind of do the same process on question 7, but for question 7, we're actually going to be solving it. We're going to be solving it completely out. And so what we do first is we find what numbers are not going to be in the domain. And I'm first going to factor. So let's try to factor out that x squared, that plus 5x and minus 24. And all the factoring in this section is going to be relatively easy. You shouldn't really have to do hardly any factor by grouping. There's going to be a quick factor, because we need to see how it lines up with that x minus 3 and that x plus 8. So first times the last is a minus 24. And because we know it's a minus 24, that tells us one number is positive and negative. And then we look at the sign in the middle. Sign in the middle is positive. So we need two numbers now that are going to multiply together. So we can see here, multiply together to give us 24, subtract from each other to give us 5. So can you tell me what two numbers would multiply to give you 24, Subtract to give you 5. It looks like it's, yep, 8 and 3. Yep, very good work. 8 and 3. Now, we do not have to do factor by grouping because there's no number in front. So we can jump directly to our factors here. So before we start figuring out what numbers don't work, we need to factor and clean everything up first. So that's what we did. So that's where we began. Now we need to see what numbers are not possible solutions, not in that domain. So we look at each denominator separately. And then we need to ask ourselves, okay, so what numbers are not going to make it work? And you can either work them out or you can kind of look at them and see. I think you can kind of look at these and see, okay, so what number minus 3 makes it 0? Well, what number minus 3 makes it 0? Of course, that's going to be 3. Because 3 can't be in the domain because 3 minus 3 down below is 0. And you could solve that if you need to, because you could do x minus 3 equals 0, which would then give you 3. So these are not possible solutions. Same thing with the next one. X plus 8 equals 0. So negative 8 is also not a solution. And then they're already up in here, so they're gone as well. So these are not solutions. And if our answer comes out to either one of these, then we have no solution. Okay, so we see what numbers can't work, we take them out first. Now, once we figured out what numbers cannot work, and that step is over, then what we do is we clear the fractions. So we're going to go ahead and clear these fractions out. And we look at them as a whole and we see what we need. So when we look at this to clear them out, we look and we see, okay, so this one has an x minus 3. So we're going to have to use an x minus 3. And then we look here, and this one has an x plus 8. So we also need an x plus 8. And this one has an x minus 3, so that's taken care of in blue out in front. And this x plus 8 is also taken care of here. So everything's going to be canceled out. Now we start distributing through. So when we distribute through, let's see what we've got. And we do each one individually. So the x minus 3 and the x minus 3 will cancel with this one below. And so then our first one, we're left with that 3 on the top times an x plus 8. And then on the second one, the x plus 8's cancel, and that leaves you with a 7 times an x minus 3, because those cancel. We're still left with that. And then on the right-hand side, the x minus 3's cancel, the x plus 8's cancel, so we're left with a 5. Are you kind of with me so far there? Now all we do is distribute, and we solve it. So most of it is now done. So we distribute that 3 through, and we distribute that 7 through. So we'll distribute both of those through. And that gives me then 3x plus 24 plus 7x minus 21 equals 5. And we'll clean this up a bit. So 3 and 7 makes it 10 when we put those together. So that's 10x. And 24 minus 21, that makes that then a positive 3. Let's make sure I didn't make any mistakes, but everything looks good so far. We got to this point. Now we just need to solve it. So move that 3 over. And that leaves me then with 10x equals 2. We'll divide by that 10. And that gives us x equals 1/5. Is that a legitimate possible solution? Yes, it is. Why is it a legitimate possible solution? Well, it's a legitimate possible solution because what numbers will not work? What numbers won't work are 3 and negative 8. So is this 1/5? Is this 3 or this negative 8? It is not. Okay? If it would have been either a 3 or a negative 8, you would have no solution. That 1/5 does work because it is not either of these numbers here. Okay? So that's kind of how you solve one of those. And you're going to solve question 9 in a very, very similar manner. And same thing with 4. So that was question 7 there. So that's the one I picked for that. Okay, so now we've talked about the fractions and how they kind of work. Next, I think we'll talk about the work problem. And I'm just covering them in the order in which we covered them in the lecture, so that way it all kind of makes sense too. And so we're going to look now at question 17. And this is an application, but unlike the applications that we worked with in 1.5, this is going to be a much, much simpler problem to work through. And these are work problems. And when we work with these, we can't just look at the 6 and the 7, because that's how long it takes to do the project. Right? Because let's think about how these work in real life. If I say it takes me 12 hours to clean a house, and someone else can clean the same house in, let's say, 10 hours. If we're working together, we wouldn't just add them, because 12 plus 10 is 22, and you know it's going to take less time. Because if I can clean it in 10 and someone else takes 12, well, obviously, if we work together, it's got to be less than 10. So what we have to look at is we have to look at what portion of the project is done in 1 hour or 1 minute, whatever it might be in terms of. And so we look at it as a fractional component. So Frank can type a report in 6 hours. It takes James 7 hours to type this report. How long will it take? How long will it take the two of them typing together? Well, these are going to add together, of course, and we can't just add them together, because 6 and 7, if we added them together, would be 13. And we know it's not going to take 13 because Frank can do it himself in 6 hours. So we know it has to be less than 6 hours. So what we look at is how much is done per hour. So we look at Frank. And we say it takes Frank 6 hours to complete this project. So how much is done in 1 hour? Well, if it takes him 6 hours to complete this project, then in 1 hour, he's done 1/6 of the report. Right? So that's how much is done in 1 hour for Frank. What about James? Okay, James is a little bit slower, and it takes James 7 hours to type this report up. So how much does he do in 1 hour? Well, he does 1/7. It takes him 7 hours, so it's then 1/7 is done per hour. We're going to let x equal the time. The time that it takes them working together to type up this report. And now we'll go ahead and build our equation. So let's talk about Frank. Okay, so Frank, how much does he do in 1 hour? Okay, so Frank does 1/6 of the project or report in an hour. So that's going to be 1/6, and we put the x there. Now James is a little bit slower, and he's got 1/7. And we don't know how long it takes him, so we put the x there. And then what is it going to equal on the right-hand side? This is always going to equal 1. Because that's 100%. Right? We're typing one report. We're completely doing that report, so that's your 1, that's 100%. They're always going to equal 1. We can be filling up a sink. We can be, like in question 16, cleaning up a yard. Okay, we're going to clean up 1 yard, we're going to paint 1 house. In this case, we're going to type 1 report. So when you build your equation, it's always 1. And we're going to have the fractions because we have to look at how much work they do per hour. And so we have to make it a fraction so we know how much they do per hour. And now we just simply solve it. So we clear out our fractions. 6 and 7 have nothing in common, so we'll use a 42. And 42 divided by 6, well, that's a 7x. 42 divided by 7, that's a 6x. And 42 times 1, that's a 42. And these are very, very simple to solve. Add them together, we get 13x equals 42. Divide by our 13. And that gives us then x equals 42 over 13 hours. Now let's see if that actually makes sense. So what do we know here? Well, we know that Frank can do it by himself in 6 hours, right? So our answer has to be less than 6 hours. If it's more than 6 hours, then we know we made a mistake because he could do it by himself with no helper in 6 hours. So let's see what we've got here if we just use our calculator to check real quick. When we take 42 divided by 13, see, that's a little over 3 hours. And that makes sense, right? Because Frank and James are close together in the same amount of time. Frank does it in 6, James does it in 7. So if we figured there were 2 Franks at 6 hours, that would be half, and that would be 3 hours to do it. So James is a little bit slower, so it's going to take a little bit more than 3. So your answer should somewhere be between 6 and 3. And it is, right? That's a little bit closer to 3, and that's where it should be because that makes sense. If you've got a helper, it's going to take less time. Yep, and just leave it as a fraction just like that. You don't have to break it up. You can if you want to, but we'll just leave it as a fraction just like that. And that's okay for this application because that's how the textbook does it. So they just leave it as a fraction. So that's how we work through the applications. And question 16 is very, very similar. It's almost identical. This was 17. 16, you'll be able to do the exact same thing. Only difference is instead of it being a report, you're raking leaves. We've got a couple other types left to do. And we're going to go ahead now and look at question 1. And question 1 is an application that has a square root in it. And when we look at this, we need to think in terms of opposites. And so if you remember back in 1-4, when we solved something that had a square, we used a square root to get rid of it, right? Because a square and a square root, well, they're opposites. So the same principles are going to apply here. We have a square root. And so what undoes a square root? The opposite of a square root is a square. So we're going to go ahead and square both sides. And that may force us to FOIL. But we're going to go ahead and square both sides. Now the left side is easy because when you square a square root, they cancel out. So the left-hand side, the square and the square root, those go away. So the left-hand side is easy. That's just simply x plus 3. However, the right-hand side, we have to FOIL. Because it is x minus 3 and x minus 3. So we're going to have to FOIL this out. So So let's get our pieces and then put it back together. So we've got x times x. Well, that's an x squared. X times a negative 3, that's a minus 3x. Inside and inside is a minus 3x as well. Last and last is a positive 9. So then that is x squared minus 6x plus 9. Okay, and these do take a little bit of time to go through, but they're really not that difficult. We've kind of done these before on how to solve it from here. Because once you've got rid of the square root, that's the only new component. And we know that from this, we've got the squares, so we're going to have to set this equal to 0, right? And we're going to have to factor it just like we always would. So we FOILed it out. We got to this point, so I'm going to move that x over and move that 3 over. And that is going to leave me then with x squared. We've got a minus 7x. And 9 minus 3 is a positive 6, and that equals 0. And again, these should be fairly easy to factor. You shouldn't have to do a lot of factor by grouping. First times the last is a 6. We know the signs are the same. We know the sign in the middle is negative, so they're both negative. And we need two numbers now that are going to multiply together to give me 6, add together to give me 7. Yep, not 7, 6 and 1. Yep, you have the right concept there. And the way I remember that is I look at my 6 and I look at my 7. It's only off by 1. So it's got to have a factor of 1 in there. And now we've got x minus 6. X minus 1 equals 0. So x minus 6 equals 0. So one possible solution is 6. And x minus 1 equals 0. So x equals 1 is another possible solution. And I say they're possible solutions because for the square roots, and only for the square roots, we have to actually take it, plug it in, and see which one works. Because they might both work, neither one might work, or only one of them might work. So we're going to go ahead now and check these out. So let's check x equals 6. I'm going to check it back in the original. So I'm going to check that in the square root of x plus 3 equals x minus 3. And I'm going to plug in that 6, and I'm going to see if we get the sides to be the same. And if the sides come out to be the same, then we know we did it correctly. And so 6 plus 3 makes it the square root of 9. And 6 minus 3 is 3. And we know the square root of 9 is 3. And the other side is 3. So we know now x equals 6 is an answer. And we have to check both of them. So we're going to check x equals 1 next. So we'll plug in the 1. And that's going to now be when we plug it back in the original. And we're going to plug it back in our original here. So we're going to plug in that 1. And that's going to be the square root of 1 plus 3 equals 1 minus 3. Well, 1 minus 3 is a minus 2. And 1 plus 3 is a 4. Okay, and we have to make sure the signs are the same, because a lot of times they'll be the same numbers but different signs. They have to be the exact same signs, exact same numbers. And this is not going to work with the 1 because the square root of 4 is 2. And the other side is a negative 2, so they don't match up. So x equals 1 is not going to be an answer because it doesn't work. So the only one that we have is x equals 6. That's the only answer because the 1 just doesn't work for us. And that was question 1 there. So we'll look at a couple more just so we have one of each type again. Question 3. And these are out of 1-6. for this type of question, what we need to do is we need to clear out these fractions. Because we don't want fractional exponents or fractional powers. And so what we're going to do is we're going to clear these out. Now, think about clearing out denominators. If I had a half and I had a 4, the least common denominator would be a 4, right? So we'd multiply everything by a 4. Same concept here, but we're taking it to the 4th power. And that has to be distributed through, because we want to get rid of all of our fractional powers, our rational exponents. That's the goal. And so when we look here, what we've got, when we distribute that 4 through, 4 times a half. Well, 4 divided by 2 is 2, times 1 makes it a 2. So the left-hand side is going to be an x squared. Does that cancel? And that's what we want. We don't want no fractional powers. What about the right-hand side? Well, the right-hand side, we need to find 3 to the 4th, because that's our first step here. And 3 to the 4th is 3 times 3 times 3 times 3, which is 9, and another 9, which is then 81. And 4 and 4, those cancel. One's on top, one's on the denominator. And so that just leaves you then with an 81x. Okay, and that's it. Now all we have to do is solve it. And this is going to be very simple. We just move that 81x over. And then we simply factor, because it's set to 0 now. So that's what we needed to do. We needed to make sure it was set to 0. And now we factor. So we factor out an x, and that leaves me then with an x minus 81. And we get our two solutions, which one solution is the trivial solution, the non-essential solution, which is 0. And that is a solution still. But normally don't have to use it, but it's there. And then the other one is x minus 81 equals 0. And so x equals now 81. And so those are our two solutions. Now the good thing about this one is we don't have to check it. The only ones that we have to check are questions that involve either a square root, where we have to actually plug it all the way through, or one that has a fraction, because we don't want division by 0. Okay, well, let's go ahead and quickly review question 12, and it's easy also. Okay, now, question 12, it's a different kind of root. And it's simple to do, but we have to think in terms of opposites again. So we talked about the square root, and the opposite of a square root is a square. So in this case, we've got a fourth root. So let's go ahead and take both sides to the 4th power. That'll clear out that fourth root. And when I do that, then that gives me x squared minus 10, because the fourth root and the 4th power, see, they cancel. And 1 to the 4th power is still 1. Now, we're going to be able to quickly solve this, and I'm going to apply the square root property. You could also set it to 0 and factor as a difference of squares, but I'm going to go ahead and apply the square root property. So I'm going to add that 10 over. And now I can apply my square root property. And how do we get rid of a square? Well, we get rid of a square by taking a square root. And remember, from 1-4, whenever we take a square root, we add in a plus or minus. So that leaves me then with x equals plus or minus the square root of 11, which is then x equals the square root of 11. And x also can equal negative square root of 11. So those are your two solutions for question 12. And just to review one more, we'll look at 15. Okay, so we're going to go ahead and look at 15 here. Well, what we need to do when we solve this type of equation is we think about it like it was an x squared. If it was an x squared here instead of an x to the fourth, we would set it to 0. And that's what we're going to do here. We're going to go ahead and set this to 0. And now we're going to factor it just like we would before. First times the last is a 720. And 720 is positive. Sign in the middle is negative, so they're both the same. In this case, they're both going to be negatives. Now, sometimes you may encounter something with large numbers like this and have a difficulty factoring it. When I look at a large number, I look and I say, okay, so what does it have in it? It ends in a 0. So that automatically tells me that it has to have a multiple of 10 in it, no matter what. So we're just going to try multiples of 10 until we get it. So 720, divide that by 10. If I use 10, that's 10 and 72. Now 10 plus 72 is 82. And we're close because we need a what? We need an 89. Okay, let's try 20. 20 and 36. That's a 56. We're going the wrong direction. Now it does end in a 0, so it's either going to have, and it could have a 5. Normally it'll have a multiple of 10 in it. It could have a 5 in there as well. So we tried 10. 10 was, here I'll show you how to trap it. Okay, so 10. When I took 720 and I divided it by 10, I got 10 and 72. 72 plus 10 was 82. We needed an 89. Now, notice when I went up and I tried 20, that's 20 and 36, and when I add them together, that's 56. We're going the wrong direction, right? The first one was 82, and we knew that we needed to be smaller. So we tried 10, and that didn't work. And it went up, and the number starts to get bigger, or sorry, smaller, and we needed to get bigger. So how about we try a 5? But we know it has to either end in 5 or 10, and I thought it would probably be a 10, but we'll try a 5. So let's just try 5 here. 5 and 1, 44. Does that work? Nope. Okay, so we got to try some more numbers, but we know it's got to be bigger than 5. How do I know it has to be bigger than 5? Because when I put them together, what does it give you? 144, and that's way bigger than 89. So let's try an 8. See if 8 will work. 8 and 90. Okay. 8 and 90 is a 98. We need an 89, so we're still too big. Now we know 10 is 82, and it's too large. We did an 8, so let's try a 9. 9 and 80. Does that work? Yep. Okay, so we need an 80 and a 9. And you could have just said it ends in a 0, and I could have just sat there and tried multiples of 10 till I got it. 10, 20, 30, 40, 50. I would have eventually got it that way too. Or you can say, okay, I've trapped it. I know we need a bigger number or a smaller number, and kind of figure out where it lies in between. But once you got the numbers, then you just rewrite it as x squared minus 80. X squared minus 9 equals 0. And this is actually going to give me 4 solutions. And I get 4 solutions because the highest power is 4. And that tells me at most how many I'm going to have. So I can have up to 4 solutions. And I'm going to get 4 solutions because each one of these has 2 solutions apiece. And so the first one is x squared minus 80. And moving that over, that's x squared that equals 80. It's not an x anymore, it's an x squared. So we use our square root property to get rid of the x squared. And then we may need to factor 80 down. So let's see how we can factor 80 down. I believe 80 has a 16 in it. Yep. 80 factors into 16 and 5, and 16 is 4 and 4. So there's a perfect square. So that gives us then, when we break it up, plus or minus 4, because that comes out. Square root of 5 is left over. Now we do the other one, which is even easier. X squared minus 9 equals 0. So x squared equals 9. We take our square root to get rid of that, and we use a plus or minus. And 9 is a perfect square of 3. We've got 4 solutions, and I'm going to list them out. So we have 4 square root of 5. We've got minus 4 square root of 5. We've got 3, and we've got a minus 3 as well. So we actually have 4 solutions. And the reason why we have 4 solutions is the fact that our highest power was 4. And the highest power kind of gives you an indication of how many answers you can have at most. It doesn't mean that you're actually going to have 4. It says you can have up to 4. Okay. So I believe that should cover most of the questions that we had out of 1-6. Now we did part of 1-7 last time, so we're going to go ahead and finish up 1-7 now. And if you want to see the other questions that we covered out of 1-6, they're going to be in the notes, and I'll post those online right after class. But let's now try to focus on 1-7. And we kind of started this last time, and we'll review it a little bit before we just jump right in. Because we did start it a little bit last time. And 1-7 is inequalities. And so with these inequalities, what we're going to be doing is we're going to be graphing them. And we need to remember that strictly greater than, strictly less than, those get parentheses. Greater than or equal to, less than or equal to, those get brackets. And positive or negative infinity, remember those get parentheses as well. So when we go to graph these, we've got to remember whether it gets a parentheses or whether it gets a square bracket. Now we'll just do a quick review of a linear inequality. We covered these last time, but we're just going to do a quick review of a linear one. Then we'll look at one quadratic one, and then we'll start the new part, which is the rational ones. So let's do a quick linear one. And linear just means there's no powers on the x. So these are just straightforward solving simple linear inequality. I'm trying to make one that's very, very simple, just so we do a quick review. You've seen these before in elementary, you've seen these before in intermediate, and now you're seeing it again in college algebra. And this is one of the simplest questions that you can have. You want to solve it. Okay, it's an inequality. So we solve it by just moving things around. So we move the 5 over, and we move the 9x over as well. And 8 minus 9, well, that makes it a single x, and it's negative, right? Because 8 minus 9 makes it a minus x. Now, the inequality symbol stays the same. And on the right-hand side, we have minus 14 and a minus 5. That makes it a minus 19. Now, I made this one up on purpose to be very easy to solve and also to illustrate one of the facts that we have to remember. And hopefully you all remember, whenever you divide by a negative number in an inequality, what does that do to my symbol? It flips it, right? So when we divide by a negative 1 here, that's going to make that flip around. And negative makes it then a positive 19. And we flipped our inequality symbol. And now we go to graph this, so we put that 19 on the number line. And we look at the way it points. So it points to the right. And so that means we shade to the right. And this is saying that x is bigger than 19, bigger than or equal to. So that means we have to use a square bracket. And it's pointing to the right. So we shade to the right. And what does our answer look like in interval notation? Well, it looks like 19 to infinity, right? Should not have any trouble at all with this type of inequality. It's linear. It's what you're used to solving. We've done these in numerous other classes. Now, last time we did also look at a quadratic. So we're going to look at one quadratic. Then we'll take a short break. Then we'll come back and we'll look at rational inequalities. And then that'll finish up this section. And 1/8 is going to be a shorter section as well. Because 1/8 is things you've already covered before. They're absolute values. So they don't take as long to do as some of the others. So let's look at one of these. It's a nonlinear. Sometimes called quadratic inequality, depending upon how many terms you have. And I'm going to make this one very, very simple as well. Okay, so what we're going to do is we're going to solve this. And we're going to treat it like it was an equals. And then once we've done that, we're going to get our answers, but they're critical points. And they go back on the number line. And then we have to check regions. So the first thing we're going to want to do is I always like to box it so we don't lose it. Because this is what we're going to have to be checking it. So when we get our answers, we're going to have to check it in this. You can check it in this one. You can check it in the next step. But you've got to eventually check it in the inequality. You can either check it at the very beginning, or you can check it in your factored form. It doesn't really matter. We'll just check it at the beginning. It's going to be easy enough. So I'm going to replace that with an equal sign. And then I'm going to solve it. And again, they should not be difficult at all to factor. They're going to be simple factoring equations. Right? And you can tell my numbers are 4, and what two numbers multiply to give me 4, add to give me 5. Yep, 1 and 4, right? Yep. Or 4 and 1. Yeah, either way you want to say it. But you have the right idea. Yep, because there are 5s here. We want two numbers to give me the 4. So that's going to be 4 and 1. Jump to our answers. Our factors here, and that then gives us our answer. So x plus 4 equals 0. So x equals a negative 4. And x plus 1 equals 0. So x equals now a negative 1. And these are our critical points. And we already covered this last time, but we're just kind of reviewing again. So when we look at these quadratic or these nonlinear ones, depending upon the powers, depending upon what it's called, but we factor it and we get our critical points. Now our critical points are not our answers. What we do with our critical points is we put them on a number line. And the critical points are where it switches from true to false. That's what they do. So we put our critical points on a number line. And we think of it as like a loaf of bread. And if I've got a loaf of bread and I cut it in 2 pieces, and I cut it twice, I get 3 parts, right? If I slice here and here on the loaf of bread, I would get 1, 2, 3 pieces. Now what we have to do is we have to check each piece to see if it's true or false. And we do that by picking a number that's inside that region to check back in the original. And we've got x minus 4 here. So we need a number that's in this region. And remember, this is negative infinity here. So we need something that's less than negative 4. Well, a number less than negative 4, and the easiest one to pick is going to be the next number, which is negative 5, because it's less than that negative 4. And then we need a number between minus 4 and minus 1. Well, we can use a minus 3. That's in between them. You could also use a minus 2. But just pick a whole number if possible. And then for the last region, we need a number that's bigger than a minus 1. And so easy enough. Let's use a 0. And so now that we've got those critical points, we put them on the number line, we determined our regions. Now we put them back in and check each one to see if it's true or if it's false. Back in the original. So we check it, and we'll start with negative 5. And so I'm just going to simply plug that in. And sometimes you can just look at signs. In this case, we'll just have to work it out because it's got the negative 4 in there. We plug that number back in. Negative 5 squared is 25. 5 times a negative 5. Okay, when we plug that in, that's a negative 25. And then we get 0. All right, so is 0 smaller than than a positive 4? 0 smaller than a positive 4. Yes, right? 0 is smaller, so that means this region is going to be true. Now we check the negative 3. And most of the time, but not always, they're going to switch back and forth between true and false. But you have to be careful because it doesn't always do that. In most cases, it goes true, false, true, or false, true, false, but not every single time. So you have to check. 3 squared is 9. 5 times a negative 3, well, that's a negative 15. And 9 minus 15, well, that makes it a minus 6. And is minus 6, is that true or is that false? I'm sorry, that should be a positive. Did I make a mistake on the last one? Yep, I wrote it down wrong.
Okay.
Yep, I wrote it down wrong. That was my mistake. This side should be false. Sorry about that. I just accidentally wrote down a negative or a positive point instead of a negative one. Sorry about that. So that side should be false. That was my mistake there. When I was copying it, I just wasn't careful because that's what we're checking is here. And that was my mistake. So thank you, Tracy. Because now this one, what do we know about this one? Okay, is negative 6 smaller than a negative 4? That one is true. Now, yep. So always go back and make sure you don't make a simple mistake like a sign error. You know, we all make them, but try to have as few of those as possible. And let's try 0. If I plug the 0 in, okay, all those zeros makes the left-hand side 0. And is 0 smaller than a negative 4? Is 0 smaller than a negative 4? Nope, that would also be false, wouldn't it? Okay, now we've got these pieces labeled. And what we want is we want the section or sections that are true. So in this case, the section that is true is right in the middle, region 2. And we use parentheses because of the fact that it was strictly greater than or strictly less than. So what does my answer actually look like? It's this region, and in interval notation, that region would then look like -4 to +1. And so there is your final finished answer. Let's take a short break. We're going to come back and we're going to look at the fraction ones, the rational inequalities, and they're handled in a similar manner. So there's not much difference to them. Once we do that, then we'll look at the applications. I'll help you set them up. 1/8 should not take us long to go through. We should be able to do 1/8 in about an hour. And then we'll see if we're going to have our test on Wednesday of next week or not. Because we won't have class on Monday because that's the 4th of July. But we'll just see how much time we have left. So we'll take a short break, come back, and finish up 1/7.